stop everything you're doing. In less than 3 days, something unprecedented is about to happen. NASA's Europa Clipper spacecraft will fly directly through the ion tail of 3I Atlas. That mysterious interstellar visitor ranked 4 out of 10 on the Alien Detection Scale. For the first time in human history, we're going to collect particles from another star system. Not observe them from millions of miles away. Actually fly through them, touch them, analyze their chemistry. But here's the problem nobody's talking about. Europa Clipper might be asleep. The US government shutdown means the spacecraft is in cruise mode, its instruments powered down. And scientists have 72 hours to wake it up before this once-in-a-lifetime opportunity passes forever. The window opens October 30th. That's 3 days from now. If Europa Clipper's magnetometer and plasma instruments stay offline, we miss our shot. And 3I Atlas won't be back. It's leaving the solar system at 210,000 kilometers per hour, never to return. Here's what makes this urgent. In just 2 days, on October 29th, 3I Atlas will reach perihelion, its closest point to the Sun. When that happens, it will erupt, releasing maximum material: water vapor, carbon dioxide, cyanide gas, nickel vapor, all being blasted into space by solar radiation, creating an invisible river of charged particles streaming millions of kilometers across the solar system. And Europa Clipper is heading straight into it. Between October 30th and November 6th, the spacecraft will be immersed in this ion tail. 8 million kilometers from the comet itself, but directly in the path of particles that originated from a world we'll never visit, around a star we may never identify. But there's a twist. There's a second spacecraft. The European Space Agency's Hera probe, currently traveling to the Didymos asteroid, is entering the tail right now, between October 25th and November 1st. Except Hera doesn't have the right instruments. It can't detect ions. Europa Clipper can, if it wakes up. Here's the question that's keeping astronomers awake at night. What if those particles reveal something unexpected? What if the isotope ratios don't match anything natural? What if the organic molecules show signatures we can't explain? Because remember, 3I Atlas exhibits 8 documented anomalies that defy conventional explanation. And in 72 hours, we might find out why. Stay with me. I'm going to explain exactly what Europa Clipper will be looking for, what it means if they find something strange, and why this moment could be the most important scientific event of 2025. Let's go deep. Let me lay out the science. 3I Atlas is releasing material as it heats up near the Sun. This material gets ionized. Ultraviolet radiation strips electrons from atoms and molecules, creating charged particles called ions. These ions get caught by the solar wind, that constant stream of charged particles flowing outward from the Sun at hundreds of kilometers per second. The result? An ion tail. It's invisible to our eyes. You can't see it in photos. But it stretches millions of kilometers through space, always pointing away from the Sun. Think of it like a river current in space. Particles from the comet get swept downstream by the solar wind. Now here's where it gets interesting. 2 researchers, Samuel Grant from the Finnish Meteorological Institute and Geraint Jones from the European Space Agency, they built a computer program called Tailcatcher. It tracks solar wind packets. By knowing where 3I Atlas was and calculating the solar wind's path, they predicted where those comet ions would end up. And their calculation showed something remarkable. Europa Clipper's trajectory will intersect with the predicted path of 3I Atlas's ion tail between October 30th and November 6th. The spacecraft will be flying through a region of space where particles from an interstellar comet should be passing by. Europa Clipper has the perfect instruments for this. Its plasma instrument can detect charged particles. Its magnetometer can measure distortions in the magnetic field caused by those particles. This isn't luck, it's serendipity. The spacecraft was built to study Europa's potential ocean, but its equipment can also sample cometary ions. Hera, unfortunately, lacks these capabilities. It can't detect the ions or the magnetic signatures. So Europa Clipper is our only shot, if its instruments are active. If mission controllers can communicate with the spacecraft in time. If the government shutdown doesn't prevent the necessary commands from being sent. Here's what makes this so valuable. When you detect cometary ions, you can distinguish them from regular solar wind. How? Chemistry. Solar wind is mostly hydrogen and helium, lightweight, simple. Cometary ions include water molecules, carbon dioxide, carbon monoxide, heavier species. They have distinct chemical signatures. Europa Clipper's instruments can measure these differences. They can tell you not just that particles are present, but what those particles are made of. And that's where things get profound. If Europa Clipper successfully samples the ion tail, scientists want to answer several questions. First, what's the production rate of different molecules? How much water versus carbon dioxide is being released? This reveals 3I Atlas's composition, which tells us about the chemistry of its home star system. Second, are there unexpected elements? Ground telescopes can only detect certain things. Direct sampling might reveal trace elements that don't show up in remote observations. Nickel vapor, for instance. That was detected spectroscopically. But what else might be there? Third, what's the isotope ratio? This is critical. Isotopes are versions of the same element with different numbers of neutrons. The ratio of different isotopes tells you about nuclear processes, stellar environments, the age of material. If 3I Atlas is truly 7.6 billion years old, older than our solar system, its isotopes should reflect that ancient origin. Fourth, are there complex organic molecules, amino acids, nucleobases, the building blocks of life? I'm not suggesting 3I Atlas harbors life. But if the star system it came from ever had biology, comets could theoretically carry traces of that extinct life through space. It's unlikely, but not impossible. Let's address the elephant in the room. Could Europa Clipper's data tell us if 3I Atlas is artificial? Here's the honest answer. Maybe. It depends on what's found. If 3I Atlas were a probe using propulsion, the exhaust could appear in the ion tail. But those products might not look dramatically different from natural outgassing. A spacecraft using water as propellant would release water vapor. That ionizes and creates an ion tail just like a comet. However, there could be subtle differences. Artificial propulsion might show isotope ratios that don't match natural processes. It might release elements that shouldn't be there. Enriched uranium. Specific isotopes of hydrogen or carbon that indicate industrial processing. These would be red flags. Additionally, if 3I Atlas is braking, slowing down to enter the solar system, the thrust would create asymmetric outgassing. More material released in one direction than another. Europa Clipper's magnetometer could detect asymmetric magnetic structures that don't match natural comet behavior. I want to be clear. Most scientists believe 3I Atlas is a natural comet. But the 8 anomalies it exhibits, the anti-tail pointing toward the sun during July and August, the ranking of 4 out of 10 on the Loeb scale, these things keep the question open. And Europa Clipper's data might provide clarity. The window is incredibly narrow, October 30th to November 6th. Just 1 week. After that, Europa Clipper moves past the region where the ion tail is predicted to be. Miss this window, and the opportunity is gone forever. Why is the window so narrow? Because solar wind speed varies. The tailcatcher program calculates the most likely path of the ions, but there's uncertainty. If the solar wind was faster or slower than predicted, the ion tail could be in a slightly different location. Europa Clipper has to be in the right place at the right time. And here's the added pressure. 3I Atlas is currently hidden behind the sun from Earth's perspective. We can't observe it directly right now. We won't be able to re-observe it until late November. So when Europa Clipper flies through the predicted ion tail region, we won't have real-time confirmation that the tail is actually there. Scientists are flying blind, trusting the mathematical models. This is science at its most uncertain and exciting. We have calculations, predictions, sophisticated models. But until the data comes back, we don't know if this will work. And if it does work, we won't know what. The data will show until months later, when it's transmitted back to Earth and analyzed. Whether Europa Clipper detects the ions or not, this attempt is significant. It demonstrates that we have the capability to sample interstellar objects, not just photograph them, not just measure their light, but actually fly through their material and collect data. This is unprecedented. Oumuamua, the first interstellar visitor, caught us unprepared. It was already leaving the solar system by the time we realized it wasn't from here. 2I Borisov, the second visitor, we observed extensively, but never got close. 3I Atlas is our third chance, and this time, we have spacecraft in position to do something we've never done before. If the data reveals natural composition matching solar system comets, we learn that comet chemistry is universal. The building blocks of planetary systems look similar everywhere. If the data shows differences, isotope ratios that don't match, unusual elements, we learn that different star systems produce different chemistry. Both outcomes are valuable. And if, against all odds, the data shows something we can't explain, something that doesn't fit natural processes, then we have a mystery that demands deeper investigation. That's what makes this exciting. In 3 days, on October 30th, Europa Clipper enters the predicted zone. Between then and November 6th, its instruments, if activated, will be sampling particles from another star system. The first time humanity has done this. The first time we've touched material from a world beyond our sun's influence. What will it find? Will the isotopes match? Will there be surprises? Will the magnetic field show anomalies? We won't know immediately. The data has to be transmitted to Earth. Scientists have to analyze it. That could take months. But when those results come out, I'll be here to explain them. This is what exploration looks like. Calculated risks, narrow windows, unpredictable opportunities. Whether 3I Atlas is a comet or something more, whether Europa Clipper succeeds or not, the fact that we're attempting this is remarkable. We're a species reaching beyond our home to touch the cosmos. Subscribe. Turn on notifications. because when the data drops, you'll want to understand what it means. And I'll be ready to break it down. The universe is full of mysteries. And right now, one of those mysteries is about to give up a few of its secrets. Let's find out together what they are.